Hey guys, so in this video we're going to learn about functions. Now what exactly is a function? Let's look at the following diagram to understand what a function is in very simple terms. What a function does is that it takes an input, okay? It takes an input, it performs a series of operations, so you can think of this function as sort of like a machine, okay, or a box in which we insert an input. The function performs a certain set of operations and processes and it returns an output. So again, a function can be thought of as something that takes an input, it takes something in, it performs an operation or a set of operations, and it returns an output. The letter that we use most commonly to represent a function is the letter f. So what this function is doing is, this function is taking an input, this function over here is taking an input, and it's returning an output. So now let's look at an example over here. Let's say that I have a function f, and remember a function takes an input and it performs a series of operations or an operation on that input and returns the output. Let's say that I have a function f that takes an input, and what it does is it multiplies the input by 2 and subtracts 3 from the result. Now how can we express this mathematically? Now usually we use the letter x to represent the input. So let's say that I have my function f over here that takes the input x, and what it does to the input is it multiplies the input by 2 and subtracts 3 from the result to give us the output. So here if my input is x, I'm going to multiply x by 2 and subtract 3 from that to get the output. So here we can say that the function f in terms of the variable input x is equal to 2x minus 3. And usually we use the letter y to represent the output. So over here, if x is the input, right, we multiply the input by 2 and subtract 3 to get the output, which is f of x. So we can say y is equal to f of x, or in terms of x, we can say y is equal to 2x minus 3. Now let's look at the formal definition of a function. A function can be defined as the following. A function from a set x to a set y, here the set x is the set of the inputs. A function will take that input and give us the output. That'll be part of the set y. So the set y is the set of outputs. So a function from a set x, the set of inputs, to a set y, the set of outputs, assigns to each element of x exactly one element of y. What that means over here is that for any given input from the set x, we should get exactly one output in the set y. The set x is called the domain of the function, and the set y is called the codomain of the function. So what that means over here is that if we look at the set x, that is the set of inputs, that is called the domain of the function. So we can say that the domain can be called the set of inputs accepted by a function, whereas the set y is called the codomain of the function. Now the set y is the set of outputs, whereas in our syllabus, or for the purposes of this course, we're going to use the term range to describe the codomain. So instead of using the term codomain, we're going to use the term range. Now they're not exactly the same thing, but for the purposes of this course, we can say that the codomain can also be called the range. And the set y, which is the set of outputs, is the range of the function. So over here we can say that the range is the set of outputs given by a function. Now the next question that we have over here is, what is the domain and the range of this function given over here? What is the domain of this function? And what is the range of this function? So let's look at a graph for y is equal to f of x. In other words, we're going to look at the line y is equal to 2x minus 3, right? And we know that the domain is the set of inputs accepted by a function. So over here what we see is that for the input x, if we plug in any real number for the input, we substitute any real number for the input x over here, we will get an output. X could be pi, it could be 0, it could be the square root of 2, no matter what it is. It could be any real number, and any real number for x or any real value of x will give us an output. So the domain, which is the set of inputs accepted by a function, here the input is x, is the set of real numbers. So we can say that x can be any real number. So here this notation means x belongs to the set of real numbers. There's no restriction. Any real value of x, okay, or any real number for x for the input here will give us an output. And we can see that graphically as well, right? This graph is extending all the way to the right and all the way to the left. And here if I substitute any value of x, I substitute any real value for x, the input over here, I will get an output. Now, what is the range for this function? The range of the function is the set of outputs given by a function. Now again, if we look at the graph over here for y is equal to f of x, what we see is that this line continues upwards as well as downwards. So depending on the value of x, the input, we can get any real number as the output for y. Right? We can get any real number as the output. So we can say that the range for this function, right, is f of x can be any real number. Can be any real number. Or if we say over here that y is equal to f of x, we can say that y can be any real number. So over here we can say that the domain for this function is the set of real numbers. That is, the input x can be any real number. And the range for this function is also the set of real numbers. In other words, the output f of x, or if y is equal to f of x, then the output y can also be any real number over here. Now let's consider some possible inputs for this function and the corresponding outputs. So here I've shown some of the elements in the set x. These are some possible inputs that the function can take and the corresponding outputs. So for example, when the input x is equal to -2, we know that the function multiplies the input by 2 and subtracts 3 from the result. So when x over here is equal to -2, the input, we get -7 as the output. So we can say that f of -2, that's the input over here, is equal to 2 times -2 minus 3. And therefore we can say that when the input is -2, the output is -7. This can be written like this. Similarly, when the input is -1, the output is -5, and so on, right? And if y is equal to f of x, we can also see the graph for this function over here. Another thing that we notice over here is that for any given input, we get exactly one output, right? That's part of the definition of a function. That if I take any input, if something is a function, it should give me one output. So if the input is -2, the output is -7. If the input is 0, the output is -3. No matter what the input, we're getting exactly one output. However, what we also notice over here is that if we change the input, we get a different output. In other words, if the inputs are different, then the outputs will also be different. This type of a function is called a one-to-one function. So what is a one-to-one function? Let's say that I have two possible values for the input. I'm going to call them x1 and x2. And they obviously belong to the set x, which is the domain or the set of inputs, right? Now, as long as x1 is not equal to x2, in other words, there are two different inputs, the values of the output have to be different. So here f of x1 will not be equal to f of x2. So this is what we mean by a one-to-one function. It means that if I change the input, I'm going to get a different output. So it is a function, first of all, because for any input, I get exactly one output. But over here, if I have two different inputs, I will get two different outputs. That type of a function is called a one-to-one function. So the function f of x is equal to 2x minus 3 is an example of a one-to-one function. Now I can also identify whether this function f of x is a one-to-one function by looking at the graph of y is equal to f of x. I can do that using something known as the horizontal line test. So let's say I draw a horizontal line on the graph for this function over here. Okay. And what I see over here is that no matter where I draw the horizontal line, the horizontal line will intersect the graph for y is equal to f of x at most one point, or at no more than 1 point. What we mean by that over here is the horizontal line obviously represents the output over here, right? So for example, this horizontal line is y is equal to -3, the way I've shown it. And y is equal to -3 corresponds to an input of 0 over here. So when the input is 0, the output over here is -3. Similarly, when the output is -5, for example, we know that the input must have been -1. Since an input of -1 gives us an output of -5 over here. So what that means over here is this horizontal line again represents the output. And no matter where I draw the horizontal line over here, because the horizontal line intersects the graph for y is equal to f of x at most 1 point, or at no more than 1 point, it means that there was at most one value of x that gave us a particular output. In other words, if I change the value of x, or if I change the value of the input, I will get a different output. That type of a function is called a one-to-one function. Now let's look at the next example. Let's say that I have a function f, And what f does is it takes the input and squares it to give us the output. So here, if x is the input, the function f takes the input x and it squares the input to give us the output. So over here we can say that f of x is equal to x squared. And here again, let's represent the output as y over here. So we can say y is equal to f of x. So therefore we can say y is equal to x squared. Now again, the first question that I have over here is what is the domain for this function? And what is the range for this function? So let's look at the graph for y is equal to f of x. Here I have the graph for y is equal to f of x. In other words, I have the curve y is equal to x squared. So I have a parabola over here. Now what is the domain for this function over here? Well, this graph obviously extends to the right and the left. What we can see over here is that the input x over here can be any real number, right? If we look at the graph again over here, right, any real number as the input, will always give us an output over here. So we can say over here that the domain is a set of real numbers. In other words, x over here can be any real number. So that is the domain for this function. Now what about the range? Well, the output over here, what the function is doing is taking the input x and squaring the input. So the output is simply x squared over here, right? So the output over here, since we're squaring the input, right, we know that the square of any number will always be greater than or equal to 0. So that means that the output over here, if you look at the graph, the possible values of y or the possible values of f of x over here, right, we see that f of x or y will always be greater than or equal to 0. So over here we can say that the range over here is for f of x will always be greater than or equal to 0. And obviously we know that f of x is going to be a real number. Or we can say because y is equal to f of x, right, the set of outputs over here will be y is greater than or equal to 0, where again y is a real number. Now the next question that I have over here is this function a one-to-one function? So let's look at some of the possible values of the input and the corresponding outputs. So over here again, the set x is the domain, and I've shown some of the elements of the set x. In other words, I've shown some of the possible values of the input and the corresponding outputs over here. Now we can clearly see that this is a function because for any given input, we get exactly one output. So for example, when x is equal to -2, we get exactly one output, that is y is equal to 4, or f of x is equal to 4. Similarly, when x is equal to 0, y is equal to 0, and so on. But what we also notice over here is that x is equal to -2 and x is equal to 2 are giving us the same output, that is y is equal to 4. In other words, -2, the whole thing squared is 4, and 2 squared is also equal to 4. Similarly, when x is equal to -1, the output is equal to 1, or when x is equal to 1, the output is also equal to 1. So even though this is a function, since for any given input we are getting exactly one output, this is not a one-to-one function because different inputs are giving us the same output. We can verify this using the horizontal line test. Here I've drawn a horizontal line on the graph for y is equal to f of x. What we see over here is that this horizontal line is intersecting the graph, or is intersecting the curve at more than one point. Now obviously when x is equal to 0, y is equal to 0. So over here the horizontal line is intersecting at only one point. However, what we also see is that there are certain points. So for example, when the output y is equal to 4, it corresponds to two possible inputs. That output 4 could be a result of the input being -2, or it could be the input being 2 over here. So this horizontal line is intersecting the graph at more than one point. If that's the case, if there's any horizontal line that I can draw that intersects this graph at more than one point, or intersects the curve at more than one point, it is not a one-to-one function. In this particular case, we have a 2-to-1 function. And the reason why is because the horizontal line is intersecting the graph, or is intersecting the curve at most 2 points over here. So again, the horizontal line represents the output, and if the output over here is y is equal to 4, that could have been the result of the input being -2, x is equal to -2, or the input x being +2 over here. So what that means is that on the graph for this function, right, I can draw this horizontal line anywhere, right? And if there is a horizontal line such that it intersects this graph at more than one point, then it's not a one-to-one function, because there are certain outputs that were a result of more than one possible input. So for example, the output 4 is a result of x is equal to -2 or when x is equal to 2 over here. So that means that despite me changing the input, I'm still getting the same output in certain cases. Hence, it is not a one-to-one function. In this particular case, it is a two-to-one function. Now let's look at the next example that we have. Let's say that I have an equation, y squared is equal to x. And the question that I have over here is y a function of x? So over here, if this was a function, we would say that x would be the input and y would be the output. But let's see if this is a function. Now we want to, because we're saying y is a function of x, we want to find y in terms of x. And if we take the square root on both sides, we get y is equal to plus or minus the square root of x. It could be the positive square root of x, or it could be the negative square root of x. And if we draw the curve, y squared is equal to x, or y is equal to plus or minus the square root of x. This is what that curve looks like. We have y is equal to the positive square root of x, or we have y is equal to negative square root of x. Now over here, let's say that x was my input, and I'm going to look at some possible values of the input and the corresponding values for the output. So for example, if the input over here, if this was a function, if the input x was 0, the output y would be 0, right? Because plus or minus the square root of 0 would give us 0. Now if the input x was 1, right, then y could be the positive square root of 1, or it could be the negative square root of 1. In other words, y could be positive 1, or it could be negative 1 over here. Similarly, if x was equal to 4, then y could be the positive square root of 4, that's positive 2, or y could be the negative square root of 4, that is negative 2. So when x is equal to 4, we can get two possible values for the output y. If the input x is equal to 4, we can get two possible values for the output y. Similarly, when the input x is 1, we can get two possible values for the output y is -1 or +1. So this over here is not a function. This over here is not a function. The reason why is that it violates the definition of a function. The definition of a function says that a function from a set x, that's the set of inputs, to a set y, which is the set of outputs, assigns to each element of x, that is to each input, exactly one element of y, that is one output. So for any given input, we must get exactly one output for something to be a function. Here, if the input is 1, we get two different outputs. We're not getting exactly one output, therefore it is not a function. Similarly, when the input here x is equal to 4, right, the output could be -2 or it could be +2. Again, we're not getting exactly one output, therefore it is not a function. And we can verify this graphically by using something known as the vertical line test. So here, if I draw a vertical line at x is equal to 4, right, that represents the input. The vertical line here represents the input, right? If the input x is equal to 4, we clearly see over here that the output y could be +2 or it could be -2. So here the output is 2, or we can see that this vertical line also intersects this curve at y is equal to -2. So again, this vertical line here represents the input, right? So we have x is equal to 4, that's our input, right? That's this vertical line over here. And it's intersecting the graph at two different points. That means that for this given input, we're getting more than one output. So what the vertical line test tells us is that if we draw a vertical line, for something to be a function, right? For something to be a function, for any valid input, we should get exactly one output. In other words, that vertical line should intersect the curve, or it should intersect the graph at only one point. If it intersects the graph at more than one point, in other words, if a given input gives us more than one output, then we can say that that relationship is not a function. So here y is not a function of x.